Welcome to another video of machine learning. My name is Naseem, and in this video we will get some hands-on experience to implement this linear regression models. We already talked about it that every time we are working with linear regression models, we would have some training data set. So as you can see on my screen, we have a training data set. In this training data set, we have two different columns, right? One is input data and second one is output data, and we will use linear regression models to get out the function, means the relationship between t1 and the x1, means what is the function going on in the back end which is giving this value t1 for each x1 x2 and for each x of this matrix. Because we are doing some hands-on in this video, we need to create this training data set. So the very first thing we will do, we will create a matrix of x, means training data set, and we need to create y, because this is our assumption. Every t in the training data set is a addition of the function value of the x, right? And here we have y, output of the function of x, and this y means output of the function is added with normally distributed noise, and in this noise would be some zero mean and standard deviation noise which we will try to create. So every time we are having x, put this x to a function, and this function will create respective y for every x, and y will be added with some Gaussian distributed noise, and this way we will get t. This is our assumption. So because we are creating synthetic data, we will use sine function, means for each x we will create synthetic data. For each x, this will be, we will give this x to a sine function, and for each x we will get y, and then after that getting y, we will add this y with the Gaussian noise, and this way we will get t1. So as a final output, we will have only two column of this training data set. One is x and second one is t, right? We already know that the relationship between t and x is sine function. Every t is an input of sine function, and the output of sine is somewhat t, right? Added with some Gaussian noise. We will use this training data set to train linear regression model to read this function, this unknown function, to the algorithm. So let's start. Very first thing, we need to create these two matrices. So go back to the spider and we need to create x. So now we will use numpy to create the synthetic data, means this test data for us. So let's go. First thing we need to do is to import numpy. We have created this np, the class instance of the numpy class. Now we will create some training data, means x data. Let's call this variable x equals to np dot linspace. So linspace is a method in numpy class which will create numpy array for us, and this array will hold element. This element should start from 0. The maximum value of the element should be 10 number of element you want to create. So for example, we want to create 50 element. This is how we can create this x. If we run this code, just press F9 two times, we will get x, right? So as we can see, x, the first element is starting from 0, and then every element is equally spaced and till 10, and we are getting 50 different elements. So you can see 49 first, because we are starting from 0 to 49. This is how we can create a array, a test array. We are creating, just start with the 10 different elements in this array, and element should start from np.pi, means this is the pi value 3.14, and the last element should be minus pi, and the number of elements should be 10. This is how we are creating. Once again, run this code. We got x. We have 10 different elements in this array. The first element is pi value, and the last element is also a pi value. Because we are starting from positive pi to negative pi, and element of the and the number of element in this array would be 10. We have created this x. This x array is having 10 different elements. At the same time, let's create y, and each y of this array would be output of the sine function of x. So just go back, create y. How we can do it? We have a function in np numpy class which is sine. We need to provide the array for which we wanted to create this sine array. So input array of this method would be x. So what this function, this specific function is doing, this is taking each element of x, creating its sine value, and then adding this output of this function into the y array. This is what it is doing. If I hit F9 on my keyboard, we are ready with the second element, right? Y. So you can see the first element is the output of first element of x, right? Let me open that too. So we have two different rows here. This is x numpy array. So for 3.14159 the value of sine function is this much. For second element base9 function is this much, and this much, this much. So same time we have 10 different element in x array, and at the same time 10 element in the y array, and these are the output of sine values of these respective element of the row. Let's close it. So as you can see, we are ready with y. We have created y, we have created x. Now it's time to create some Gaussian random distributed noise function. We need to create a array holding the same number of element, means 10 element. The element of this array should be 0 mean and some standard deviation. How to create it? Just name it noise. Again we have a method in numpy, np.random.normal, and we can provide what is the location, means mean. So we can provide, because this is 0 mean array, and what is the standard deviation of this array. So standard deviation, let's call it 0.5, and how much number of elements we want to create. So because number of elements of x and y is 10, so this would also be a 10. So let's define it 10. What we can do is we can create another variable. We can number, or we can directly say what is n, means what is the number of element. Let's call it 10 and just set this n into these matrices, right? If we run this whole code, just try to F9, what we are getting, four different variable. X is holding input values created by this function. At the same time, y is holding sine values of each element of x array, and noise is the variable which is holding normally distributed noise values of 0 mean and 0.5 standard deviation. So we have created these three things. We are ready with x1, y1, we are ready with g1. Now we need to create t, means this array, and or we already know this t array is the addition of respective elements of y and normally distributed noise matrix. So what we need to do, we need to create t is equals to y plus noise. This is what we need to do. So go back, because this is a matrix, let's call it capital T, is equals to, we have a method in np to add numpy array. So we need to supply respective arrays for which we want to add the number of elements. So because each element of y need to be added with each element of noise, right? That's it. Hit F9. What we are getting t, and this t is the first element, is the addition of first element of array y and first element of array noise. So till now we are ready with the basic basic elements. We are ready with t, we have t array, we have x array, so we are ready with training data set. We already know that the model, the linear regression model, for every new x, the value of y would be bias, which is w0, plus starting from 1 to m minus 1, m is the order of the model, and phi j of x is the basis function. We need to decide what linear regression model we need to use, whether it is polynomial or multilinear regression, means simple linear regression. So we need to decide it by analyzing the relationship between these two elements, means how the scattering means the relationship between x and t. And we already know, because x and t means t element are the output of sine functions of x, so the relationship between t and t and x would be non-linear, which is sine, and we can verify it by drawing these t and x. How we can draw? We can use matplotlib for this purpose. So analysis of the data, let's call it. We need to import, what we need to import, matplotlib dot pyplot, because this is the class we need to work as plt, right? We need to plt dot scatter, because this is what we need to do. On x-axis of scattering diagram we need to draw x, so let's write, and on the y-axis we need to draw t, so let's draw t here. And this is optional, means what is the color of the scattering diagram we wanted to have, so just write red, plt dot, and we are ready. Select these three columns, and so as you can see, the relationship between x and y is not linear. This is something non-linear, we can see, because we are using only 10 different number of elements in each class. So these are not that much dense. If we wanted to have closer look, just increase the number of the elements in the array. Just try for 100 elements and we are ready. So for 100 elements we can see the relationship between x and y is not, not linear. So because if the relationship between x and y is not linear, we need to use a polynomial linear regression, right? Polynomial linear regression is the best way to work with the non-linear data. When the relationship between the input of the training data set and the output of the training data set is not linear, then the polynomial linear regression is the best choice, right? And because we are ready with the model, and for polynomial linear regression, this basis function would be x raised to the power j for each, for each order of the element. So as you can see, this is the very basic form of our model. We are having y means predicted value, and this y is a function of new value, means for each new unknown value x, and some unknown trained coefficient which is w, right? And this is equals to w0. This we call bias, plus j starts from 1 to m minus 1. M is the order of the polynomial, right? And w1 multiply basis function. And for specifically polynomials, the basis functions have the value is equals to x raised to the power j. For when we are talking about j equals to 1, then the value of basis function will be x itself. So this would be the final form of the polynomial linear regression. We will start from w0 plus w1x for j equals to 1. For j equals to 1, x raised to the power 1. For j equals to 2, x raised to the power 2. And in the same way, for uh, j equals to m, means order of the polynomial x raised to the power m, right? If we standardize this equation, this is what we will get. So w transpose of w is the matrix, and this is the way we can get value of the w unknown parameter by using training data set. So this is how we will implement the same methods in Python to create these things. So the very first thing we need to create is to decide basis function, right? Go back to the Python and just write down basis function. Now how we can create basis function in the Python? So to create basis function, we must have two different values. So we must have x, and at the same time we must have what is the order of value of j. So go back to the spider, just create this basis function. How we can create? So def is the statement to create a basis, create a function in Python. So def, and what is the name of the function, which is basis function. Now we need two different values. We need x, and at the same time we need j, right? By using these two value, we can return what we can return x raised to the power j. This is the simplest form, means polynomial form of the basis function. So we are ready with the basis function. Next we will continue our implementation of linear regression, polynomial linear regression model in next video. I hope you are enjoying this video. I will see you in next video. Until then, happy machine learning.